All right, guys, welcome to a workshop on aerodynamic simulations for F1 cars. So this is going to be the first part of many more presentations that we have planned on the same topic. Depending upon the interest of the audience, we will continue to host this workshop. And how is today's workshop going to be conducted? Well, we'll definitely have some theoretical components, and we'll try to understand why people care about aerodynamics, especially with respect to F1 cars, though that question might be very simple. We'll basically try to understand what are some of the challenges, right? So today's workshop, at the end of the day, we are not going to be designing an F1 car, especially creating a new aerodynamic design, right? That's not going to happen in one workshop. In fact, that's not going to happen in any number of workshops, right? That is why there are racing teams. So what we are focusing on is at an undergraduate level, since F1 cars are something that people are really passionate about. So we are going to try and understand what are the necessary steps that you need to take so that you can actually run these simulations successfully. Now, when I say successfully, it is to a certain extent. By the end of this workshop, hopefully you will understand that you definitely need large computing power to run these simulations successfully. So we'll be talking about what are the things that you can do with the resources that you have. So what else have I planned for today's workshop? So in addition to talking about the theory and that in addition to talking about some of the challenges and like how you would do the aerodynamic simulations, I've also planned like a practical session. So what I did is I was able to find a model of a F1 car wing on GrabCAD. So I basically bought it and basically set up a very simple aerodynamic simulation on it so that you can basically learn from it, and in terms of settings, what are the settings that I used. So whatever you learn in today's workshop can be directly applied there. So that is the outcome that is desired, and hopefully we'll basically be able to provide that. So content, why run aerodynamic simulations on F1 cars? I think again that's a very basic question. Most of you will be able to answer it, but we'll just talk about it a little bit. And then we'll directly jump into today's main topic, like steps in performing aerodynamic simulations. And when I say steps, this is going to be the exact steps that you need to follow. There will be some recommendations based upon your models. Now, if you are currently a student who is running aerodynamic simulations, if you have a particular question in mind, this would be a great place for you to ask those questions so that I can give you customized answers. Then we will talk about how to understand results, right? So one of the confusions that many students have is that do aerodynamics is they basically get some colorful images, they plot streamlines, and they see really beautiful flow structures, but they do not know if those results make sense or not. How do you know if those results are correct or not? Then we'll talk about how much computing power you need, and then we'll finally talk about how to test new designs. I think this is where again people are struggling, and we'll definitely be able to provide some advice. For those of you who are not familiar with F1 cars, right? I'm pretty sure everyone is, but here's some basic terminologies. So pretty much every component here, especially the wings, the front and the rear wings, the barge boards, the mirrors, and the complete bodywork is designed for aerodynamic performance, and not just aerodynamic performance. Okay, so let me start with a very simple question. Now, for those of you who are like really passionate followers of F1 who really enjoy the sport, right, know that all the components are designed, every little surface area has been designed carefully. So can anyone tell me what are some of the things, like for example, based on these parts, can anyone tell me why or for what some of these components have been designed, like, and how they affect the aerodynamic performance based on your knowledge of F1 cars? So for example, let's just take the front wing. What is the front wing or what is the rear wing designed for? That is the question that I'm asking, right? So similarly, you can think of any component here and you can basically explain it. This would be a great way to share knowledge as well, right? So okay, anyway, I'll let you type it, but basically, see, when you create a vortex, right, you are not only channeling the flow, you are also creating suction effects near the mid portion of the car. Now, one of the one of the ideal or basically one of the primary objectives of any aerodynamic design is at the end of the day, you need to basically slip through the incoming air as efficiently as possible. And one of the ways you can actually do this is by creating local depressions in pressure so that the air is pulled and you can efficiently move the air from the starting of the car and towards the end of the car. I don't have an animation or I don't have an image that shows the Y250 vortex and sorry, Y240 vortex, but if you basically go to YouTube, I'm pretty sure you'll be able to see it, right? So especially with F1 cars, pretty much any component that you think of is basically used for air handling, right? Handling it correctly. In addition to this, there are also cooling requirements, right? So you have a very big engine sitting in your F1 car, which needs to be cooled, right? So air needs to be sufficiently provided through the air intake so that the cooling is also achieved. All right. So the reason why I'm kind of asking you to read up on terminologies is, especially if you're interested in F1 and if you're reading some kind of a paper or if you want to do a project, it makes sense to understand what is it that you're trying to simulate. And it makes sense to understand where that particular component is located in. If not, things are not going to be clear for you. And especially things like Y240, any F1 enthusiast knows that. Even though they are not an engineer, that is something that they know. Since many, sorry, Y250, thanks for correcting. Since many people are not aware of that, I feel like maybe you guys are not as much as a enthusiast, F1 enthusiast as Jennifer. So